Welcome, everyone. I'm excited to kick off today's presentation on statistics. Today, we'll explore some fascinating data insights and trends that are shaping our understanding. Over the next few minutes, we'll cover key concepts and interesting findings that I think you'll find very valuable. Let's get started. Now, moving on to slide 2, which covers the collection of data. This is a crucial step, because the quality of our analysis depends heavily on how accurately and thoroughly we gather the data. At this stage, we identify the sources from which we'll collect information, whether it's surveys, experiments, observations, or existing records. It's important to ensure that the data collected is relevant and representative of the population or phenomenon we're studying. Proper data collection sets the foundation for reliable results later on. So, paying attention to detail here helps us avoid errors and biases that could skew our findings. In summary, collecting data carefully and systematically is key to making our overall analysis meaningful and trustworthy. Every day, we encounter a wide range of information in different forms such as facts, numerical figures, tables, and graphs. These pieces of information come from various sources like newspapers, magazines, television, and other communication channels. For example, we might see cricket scores, company profits, or temperature changes. These pieces of information, whether they are numbers or other types of data, are collected with a specific purpose in mind. We call this collection of data. Now, extracting useful and meaningful insights from this data is what we refer to as statistics. Interestingly, the word statistics originates from the Latin word status, which means a state, especially a political state. Originally, statistics simply meant gathering data that was useful for the government or the state. Over time, however, the scope of statistics has expanded. It now includes not just collecting and organizing data, but also analyzing it and drawing valuable conclusions from it. In essence, statistics is about the entire process: collection, organization, analysis, and interpretation of data. That helps us make sense of the information we come across every day. This understanding is fundamental to making informed decisions in many areas of life and work. Let's talk about the collection of data. Essentially, it's the process of gathering and measuring information on specific variables in a systematic way. This structured approach helps us answer relevant questions and evaluate outcomes effectively. Now, when we talk about the data being collected by someone with a clear purpose in mind, we call that primary data. Think of it as data you gather firsthand, maybe through surveys or experiments. On the other hand, if the information already exists somewhere, like on the internet or in records, and you're just retrieving it, that's secondary data. Both types are crucial, but understanding their differences helps us choose the right approach for our research. Connecting this to the overall theme, good data collection is the foundation for reliable analysis and decision-making. Presenting data can often be quite time-consuming, especially when we're dealing with large numbers or trying to arrange them in order, whether ascending or descending. This is where the concept of using frequency really helps us. In this example, we look at how many students have obtained certain scores, which we call the frequency of those scores. For example, if 4 students score 70 marks, then the frequency of 70 marks is 4. Using this approach, we can organize the data into a table that's much easier to understand. This table is known as an ungrouped frequency distribution table, or simply a frequency distribution table. It helps us see at a glance how the data is spread out. Once we've collected our data, the next step is to present it in a way that's meaningful, easy to grasp, and highlights the main features quickly. For instance, if we look at a raw list of scores, it might take us some time to identify the lowest and highest scores. But if we organize those scores in order, either ascending or descending, it becomes much quicker to see those extremes. So, in summary, choosing the right presentation method, like frequency tables or ordered data, makes our analysis more efficient and our insights clearer, which is exactly what we aim for in this overall process of data presentation. Usually, when we're comparing individual items, using graphs is the most effective way to communicate the differences. You see, visual representations like graphs make it much easier for the audience to grasp the data quickly, rather than just looking at numbers or raw data. In this section, we're going to look at some common types of graphical representations that help us visualize data clearly and effectively. These tools are essential because they simplify complex information and help us see patterns, trends, and relationships at a glance. So, as we go through this part, keep in mind how these visual aids can enhance understanding and support the overall message of our presentation. Now, let's take a closer look at the bar graph. Essentially, it's a visual way to represent data using bars. Usually, these bars are of uniform width and are spaced evenly apart along one axis, which we typically call the x-axis. This layout helps us compare different categories or variables easily. The height of each bar corresponds to the value of the variable it represents, and these values are displayed along the y-axis. So, taller bars indicate higher values, and shorter bars show lower ones. This setup makes it straightforward to see patterns, differences, or trends at a glance. Bar graphs are incredibly useful because they turn raw numbers into a visual story, helping us quickly grasp the key insights without getting lost in numbers. They're a great tool when you want to communicate data clearly and effectively. This is a form of representation similar to the bar graph, but it is specifically used for continuous class intervals. As you can see, since there are no gaps between the consecutive rectangles, the resulting graph appears like a solid figure. And this, my friends, is called a histogram. Now, unlike a bar graph, the width of each bar in a histogram actually plays a significant role in how we construct it. So, understanding the importance of these widths helps us accurately depict the data, especially when dealing with continuous data sets. There is yet another way to visually represent data and its frequencies, which is a polygon. Frequency polygons are also a good choice for displaying frequency distributions. To create a frequency polygon, start just as for histograms by choosing a class interval. Then draw an x-axis representing the values of the scores in your data. Frequency polygons can also be drawn independently without drawing histograms. For this, we require the midpoints of the class intervals used in the data. These midpoints of the class intervals are called class markers. The mode is the value of the observation which occurs more frequently, i.e., an observation with the maximum frequency is called the mode. The median is the value of the given number of observations, which divides it into two exactly equal parts. So, when arranged in ascending or descending order, the median of ungrouped data is calculated as follows. We represented the data in various forms through frequency distribution tables, bar graphs, histograms, and frequency polygons. Now, the question arises if we always need to study all the data to make sense of it, or if we can make out some important features of it by considering only certain representatives of the data. This is possible by using measures of central tendency, or averages. The most common measures of central tendency are the arithmetic mean, the median, and the mode. Let's now look at some examples to understand how these measures help us summarize data effectively. So, to wrap up, we've looked at how facts and figures, when collected with a specific purpose in mind, are called data. And then, statistics is the field that helps us understand and make sense of that data through presentation, analysis, and interpretation. We also saw how data can be presented visually, using tools like bar graphs, histograms, and frequency polygons, which make complex information easier to grasp. Finally, we discussed the three main measures of central tendency: mean, median, and mode, which are essential for summarizing data effectively. These concepts are all interconnected and form the foundation for analyzing information in a meaningful way. Thank you for your attention throughout this presentation.